Hi guys, welcome back to my channel. Today we are going to see a different concept, complex numbers. So we're going to see a question, complex number, and this is from May June 2010, Cambridge A level pure math paper 970931. So let's quickly move on to the question. This question is totally 2 plus 4 plus 3, which is 9 marks. So let's move on to this question now. The complex number 2 plus 2i is denoted by u. Find the modulus and argument of the complex number. So that's the first part. So u is given as 2 plus 2i. So the modulus of u is simply the root of the real part square plus the imaginary part square. So that gives you root of 4 plus 4, which is root 8. And root 8 is 2 root 2. So that is the modulus of the complex number u. The argument of the complex number u is tan inverse of the imaginary by the real. So 2 over 2. That gives tan inverse of 1. And this is pi by 4. So that's how we find the modulus and argument of the complex number u. Let's move on to the second part. In the second part, sketch an Argand diagram showing the points representing the complex numbers. So 1, I, and u. So this one is on the x-axis, this the real axis, and this on the imaginary axis, and the u 2 comma 2. We're going to plot it. Also, we're given two inequalities here, modulus of z minus 1 less than or equal to modulus of z minus I, and the other one is modulus of z minus u less than or equal to 1. Now if you see here, first plot the points 1 and I, and join the points 1 and I, and you're going to draw the perpendicular bisector of 1 and I, and you're going to shade the region or mark the region which is closer to 1. Now how does this actually work? If you see here, it says the modulus of z minus 1, which means the distance of the z from 1, and here the distance of z from I. So it's saying the distance of z from 1 is less than, which means close to 1 rather than the distance of z to I. So that's what it means. Before that, if you draw the perpendicular bisector, we know the points on the perpendicular bisector are the points which are equidistant from 1 and I. So let's draw the perpendicular bisector first, and then we'll mark the region which corresponds to our question. So this is a perpendicular bisector. Coming to the other one, which is the modulus of z minus I equal to 1. So this is nothing but a circle with the center u. So u here is 2 comma 2, and the radius is 1. So let's draw this. In the exam, you can draw, you can use your compass to draw a circle. So here, I'm using the tools whatever available here. So I have drawn the circle with the center 2 comma 2. So this is 2 units, and this is also 2 units. This is 1 and this is 1. So now we also need to mark 1 on the x-axis, the real axis, and also I on the imaginary axis. So this is our imaginary and this is our real axis. Now first we'll connect the line. This is I. We're going to connect the line joining the points I and 1. Let's connect them. We need to draw now a perpendicular bisector for this. That's a perpendicular bisector. Uh, so here, the points that you're looking for is within the circle and also close to 1. So that's a region you're looking for. Now, so that's the second part of the question. Now moving on to the third part, what it says is using a diagram, calculate the value of modulus of z for the point in this region for which the argument of z is least. So argument of z is nothing but a line connecting the origin such that it touches the circle with the least angle. So what it means is you need to draw a tangent such that the tangent touches the circle at one point and also connecting the 0, 0, the origin. Now this point wherever the argument is least, here the argument is least because that's the least angle we get. All right. Now uh, we need to find the modulus of that. So this is a point we're looking for. So we need that distance. Now this forms, let me draw a bigger diagram so that will be easy for you to understand. So this is a radius 1 unit, and we already know the modulus of the complex number u. So this is 2 root 2, and this is a radius and this is a tangent, and we exactly need that distance. Now let's say if this is x, that is x, you can use the Pythagoras theorem, x squared plus 1 equal to 2 root 2 square. X squared plus 1 is 8. If x squared is 8 minus 1, 7. If x is root 7. Therefore, the modulus of z, in this case, it is root 7. So this is how you work out the solution. So during the exam, you have to use a scale so that at least you'll get a decent circle and also you'll not mess up with the values. But geometrically, it can be easily figured it out. So that's the solution for this question. Thank you. Please do not forget to subscribe our channel and give a like.